complex numbers. So complex numbers are also known as imaginary numbers. So if we look here at the beginning, imaginary number I is defined as the square root of -1. So this is what we use when you do get a square root of -1. Now, we've got this pattern here. And it makes it a lot quicker if you memorize this pattern. It's a pretty easy pattern to remember. So I equals I squared actually turns into -1. I cubed is equal to -I, and I to the fourth is 1. So when you're reducing complex numbers, this is the list that you want to refer to. Now this is how I remember it. Here's just an easy way. I go ahead and write down my I's. So I to the first, basically, I to the second, I to the third, I to the fourth. Okay, it goes I1 with negatives here in the middle. Okay, so just remember that pattern, I1, and then your negatives are the 2 in the middle. And that's an easy way to remember that pattern. So when you're doing negative numbers and you're taking square roots of negative numbers, square root of -81 is not going to be -9. Okay, because you've always been taught you can't take the square root of a negative number. You can't do that. So this is where the I comes in. So anytime you're taking a square root of a negative number, take the square root of 81, which is 9, and just think of that negative as turning into I. All right, so for B, square root of 121 is 11, and that negative, we're going to turn it into an I. Now on C, 50 is not a perfect square, so we do it the way that we've been doing. A perfect square that goes into 50 is 25. 25 times 2. Always pull that negative out. Don't ever leave the negative in the radical. So square root of 25 is 5. The negative turns into an I, and then you leave the 2 as the radical. All right, D is very similar. We got to reduce it. A perfect square that goes into 45 is 9. And square root of 9 is 3. That negative turns into an I. Do not ever leave the negative in the radical. Always pull it out, turn it into an I. All right, you may want to pause right here and see if you can do E through H on your own, and then you can play it when you're ready to check it. For square root of -8, that's going to be -4 times 2. Square root of 4 is 2. The negative turns into an I, and then this 2 stays in the radical. For F, square root of -12, that's going to be -4 times 3. Square root of -4 is 2. Negative turns into your I. 3 stays in the radical. For -60, a perfect square that goes into 60 is -4 times 15. Square root of 4 is 2. The negative turns into an I. And we have square root of 15. And then we get square root of -49. Remember, that turns into a 7. The negative turns into an I. It is not a -7. It turns into an I. Now we get into simplifying radicals. Treat I just like any old variable. And then what you do when you multiply everything out, if it turns into I to the second, you substitute with -1. If it turns into I to the third, substitute with -I. If you get I to the fourth, substitute with 1. So 8 times 3 is 24. I times I is I squared. Go back and refer to your list. I squared is -1. And 24 times -1 is -24. For B, -2 times -5 is 10. I times I is I squared. I squared is -1. I squared you're going to learn pretty quick. I squared is -1. 10 times -1 is -10. For C, 3 times -4 is -12. I squared and I gives us I cubed. Look at your list. I cubed, we replace with -I. And we got 2 negatives, which turn into a positive. So it would be 12I. For D, -2 times 3 is -6. I to the third and I gives us I to the fourth. I to the fourth is just 1. -6 times 1 is -6. Simplifying radicals in example 3. So you treat I just like it is a variable. So if it has an I, you can combine them. If it doesn't have an I, you can't combine it. Or you combine the ones that don't have an I. So for A, 8 plus -12 is going to be -4. 7i plus 11i is 18i. And you cannot combine 4 and 18i because it's just being like if it had an x with it. So this is our final answer. For B, negative 7 plus 4i plus 9 minus the square root of negative 36. Now, I want to change this part right here. Square root of negative 36 is going to be 6i. So I'm just going to rewrite that. Negative 7 plus 9 is 2. 4i plus, this is a negative here, so be careful with your signs. 4i plus negative 6i is negative 2i. For C, negative 7 minus 3 is going to be negative 10. 4i minus positive 2i is 2i. All right, D is similar to B. Square root of negative 4 is 2i. So 9 minus 12 is negative 3 for my like terms. Negative 6i minus 2i is negative 8i. Be very careful, especially when you're subtracting negatives. Okay, now we get into multiplying with i's. So you would multiply it, you would FOIL it out, just like we talked about before, so don't forget FOIL. I'm going to show you how to do it by hand. It is important to do it by hand, and I'm going to show you how to do this in a calculator. So first of all, let's do it by hand. 8 times 2 is 16 because I'm multiplying the first. Then I multiply my outer, 8 times negative 3i. So since I'm multiplying, it's just like you can multiply a number and a variable. We get negative 24i. 5i times 2 is 10i. And 5i times negative 3i, we get negative 15i squared. Now, these are like terms I can combine. So I have 16 minus 14i. Now remember, I squared is negative 1. So right here, I have negative 15 times negative 1, which is positive 15. Okay? And then I can go one more step. 16 plus 15 is 31 minus 14i. Okay? So if you do have a graphing calculator, what you can do is you can go and hit your mode button. And if you scroll down, you can change the mode where it's in imaginary mode. And you can type in, once you do that, you can actually type in using the I key on your calculator. So you would hit second decimal, and that's going to pull up your I. So even if you forget your list at the beginning of notes, you could always check it if you've got a graphing calculator. You can type in I to the second, and it's going to give you negative 1. I to the third is going to give you negative I. I to the fourth is 1. You can also type in just the problem here that we've got. If you make sure you put parentheses in the right spot, and it would give you 31 minus 14i. So depending on the situation, whether we're at school or at home, if I require you to show your work, make sure you know how to do this, but you can always, always, always check yourself on the calculator. If you've got a calculator, definitely check yourself. So for B, 2 times 3 is 6. Then 2 times negative 4i is negative 8i. 3i times 3 is 9i. And 3i times negative 4i is negative 12i squared. Like terms in the middle, so I have 6 plus I, because negative 8 plus 9 is just 1. Remember, I squared is negative 1, so we have negative 12 times negative 1, which is going to turn that into a positive 12. 6 plus 12 is 18, so I have 18 plus I. On C, it is squared, which means you have to multiply it times itself. You can't just go in and say 5 squared is 25 and 6i squared is going to be 36i squared. You have to multiply it out because it's not the same thing. Negative 5 times negative 5 is 25. Negative 5 times 6i is negative 30i. 6i times negative 5 is negative 30i. And 6i times 6i is going to be 36i squared. So if we combine our like terms, we get 25 minus 60i. Remember, I squared is negative 1, so that's going to be minus 36. And 25 minus 36 is going to be negative 11. All right, on D, when we multiply. Now, what's special about D, notice these are the same numbers. These are the same. But what's different is we have different signs. You've got a plus and a minus. These are called conjugates. Okay, when everything's the same except for the signs, you have conjugates, which actually means you can take a shortcut. So the shortcut for conjugates is that you multiply your first terms and you multiply your last terms, because what happens is the inside terms, your inner terms, end up canceling each other out because everything's the same and you got a plus and a minus. It means they're going to cancel out. So there's your shortcut when you have conjugates. So negative 3 times negative 3 is 9. There's my first terms. So there's my first. Now I'm going to do my last terms. 2i times negative 2i is negative 4i squared. Remember, I squared is negative 1. So we get 9 plus 4, which is 13. Okay. And we are going to save solving radicals for the next lesson. So I'm not going to do example 5 just yet. We're going to save that one for the next lesson.